Hi, today I'm going to be going over Chapter 16, A Universe of Galaxies. Big ideas I'm going to be going over today are when the idea of discovering other galaxies got introduced, such as who brought the idea around, how they did it and when, the different types of galaxies and how they're classified, such as whose classification we're using and when it came to be, what parts of the universe were most likely to find galaxies, clusters of galaxies, dark matter, the birth and life of galaxies, and the search and discovery of galaxies along with where they may be coming from, what conditions have produced them, and how long they've been there. So when did we discover galaxies? In 1770, a French astronomer named Charles Messier was interested in discovering comets, and he decided to make a list of everything he saw in the sky already so he would notice when something new was there, such as a comet. This list became known as the Messier list, and by the 20th century, several thousand nebulae and clusters had been added to the list since they were discovered. Now I'm going to be talking about types of galaxies. So in 1925, Edwin Hubble set up a system to classify the galaxies, and we still use a modified form of his classification today. I'll be going over spiral galaxies, barred spiral galaxies, elliptical galaxies, and then a few other galaxies that aren't as common as the other ones I mentioned. So first I'm going to talk about spiral galaxies. A spiral galaxy consists of a flat rotating disk with a bulge in the center and embedded spiral arms. Spiral galaxies are one of the most common galaxies found throughout the universe, and they typically have a supermassive black hole at the center. They also tend to be one of the brightest galaxies in the universe. A couple examples of this type of galaxy would be the Andromeda Galaxy and NGC 7331. The Andromeda Galaxy is said to be very similar to our galaxy, which is the Milky Way Galaxy, and NGC 7331 is said to be our long-lost twin galaxy. And though they're very similar, they have one important difference, and that is that the Milky Way Galaxy is a barred spiral galaxy. It essentially consists of the same characteristics as a spiral galaxy, but the central bulge within it instead looks elongated like a bar, and the arms of the spiral tend to stick out a little bit more. And I'm going to be showing some examples of these galaxies and their differences in the next couple slides. So this is the Andromeda Galaxy. The dark purple parts are the arms of the spiral, and if you can see, they're just very closed in within the galaxy, like they don't stick out or anything, they're pretty tight. And this is an example of a barred spiral galaxy. It's the Milky Way Galaxy, and these are the arms. Instead of them being tight within, they just kind of flare out instead. So next I'm going to be talking about elliptical galaxies. They have no discernible shape and can be found in smaller and larger forms. They are some of the oldest galaxies. The stars within them are some of the oldest stars in the entire universe. Unlike spiral galaxies, they don't form stars anymore, since they don't have much gas and dust and they can't create new stars. So instead, they are just home to stars that have lived for billions of years. And this is Centaurus A, and it's an example of an elliptical galaxy. So these are the three other galaxy types I'm going to be talking about. The first one is the lenticular galaxy. They have features of both spiral and elliptical galaxies, and they have a disc-like shape. They have no spiral arms and have very little gas or dust, much like elliptical galaxies. The next is an irregular galaxy. They have lots of gas and dust and can rapidly form stars. And then the last one is a peculiar galaxy. These look kind of like spiral or elliptical galaxies, but closer to a spiral galaxy without its nucleus. So this is ESO 162-17, and it's an example of a peculiar galaxy. This one is NGC 5866, and it's an example of a lenticular galaxy. And this is NGC 1427A, and it's an example of an irregular galaxy. So, where can we find galaxies? They're typically found within large clusters of other galaxies. A few of these clusters are the local group, the Coma cluster, and the Virgo cluster. The local group consists of about 60 galaxies and is about 3 million light-years in diameter. The Virgo cluster is the largest relatively nearby cluster, containing 2,000 galaxies with a diameter of 50 million light-years. And the Coma cluster consists of over 10,000 galaxies and is 300 million light-years in diameter. And now I'm going to be getting into superclusters. Superclusters of galaxies are typically 100 million light-years in diameter and appear to be elongated and flattened with a thickness of about 10 million light-years. The local group, the Virgo cluster, and dozens of other clusters of galaxies form the local supercluster. And now I'm going to be getting into some of the mysteries about the universe and galaxies, and one of the main mysterious things is dark matter. Much of the matter in the universe doesn't emit any radiation that's detectable yet, and still has a gravitational influence on its surroundings, and this is known as dark matter. Rotation curves are less of a mystery and more of something that's just good to know. The rotation curve helps us determine how strong the dark matter is that's present within a galaxy, and it can be discovered through studies of the motions of stars and clouds of gas. And to continue the subject of dark matter, Zwicky was the first to propose this idea, but so many dismissed his ideas, which apparently were just far too early for his time. And dark matter is really important to galaxies. Take elliptical galaxies, for example. If elliptical galaxies didn't have a large amount of dark matter, then the gas in stars would escape since they move so quickly. The visible matter alone doesn't create a strong enough gravitational field, so there must be a more dominant contribution to gravity within the galaxies. Dark matter is also very present within our Milky Way galaxy and within spiral galaxies in general. So what exactly is dark matter? It's actually unknown what it is exactly, but there's a few ideas as to what it could be. One idea is that it could be created from dead stars, black holes, or neutron stars. Another idea is that it could be from smaller black holes, the force of massive planets, and neutrinos. They could also potentially be undiscovered subatomic particles left over from the Big Bang. Gravitational lensing helps us have the opportunity to have a better understanding of dark matter. A gravitational lens is a distribution of matter between a distant light source and an observer. It's capable of bending the light from the source and bending it towards the observer. So where do galaxies come from? It's unknown where they come from exactly, but it's clear that we live in a pretty typical part of the universe where nearby galaxies are representative of galaxies everywhere. It's useful for us to look at galaxies that are billions of light years away because they most likely resemble what today's galaxies used to look like. We're able to look at these galaxies and study where they could have come from through a refurbished Hubble Space Telescope, and this telescope provides detailed images of faint, distant galaxies so we can get a better idea of what is going on within those galaxies. So what does the future of the universe look like? Well, studies have shown that most galaxies are moving away from our galaxy, regardless of their direction in the sky. And Hubble's law implies that the universe is expanding. Its premise is that the galaxies are moving away from our own, and the further away they are, the faster they are moving away from us. We can see this because the optical spectra of the spiral nebulae almost always shows a redshift, and this is assumed to be caused from the Doppler effect, and this tells us that the galaxies are moving away from us. Now let's talk about what we're doing to get a glimpse of the most distant galaxies. We use the Hubble Space Telescope to get us a clear image of faint galaxies. There are so many galaxies to observe in the universe. If we could photograph it with complete clarity, then we would see roughly 50 to 100 billion galaxies with billions of stars each. The Hubble Deep Field contains several thousand extremely deep galaxies, and the Hubble Deep Ultrafield and the Hubble Extreme Deep Field each contain even more than the Hubble Deep Field. So, galaxies have evolved over time and they will continue to evolve within the future, and elliptical galaxies are some of the oldest galaxies. They formed early in the universe. It's very well possible that they formed from the collision of two spiral galaxies. 5 to 6 billion years from now, it is also very well possible that the Andromeda Galaxy and our galaxy will either collide or just nearly miss each other, which could in turn create an elliptical galaxy. So clusters themselves formed within the last 5 billion years and are still growing today, but where can we expect to find them? Simulations have concluded that you're much more likely to see a large galaxy form within cold dark matter than hot dark matter. Hot dark matter has a hard time clustering on small scales, so they're much more likely to produce individual galaxies or small clusters. And while we have learned this about dark matter, it's still one of the biggest mysteries of the universe. Alright, and that's my presentation concluded. Thank you so much for listening. I loved learning about dark matter while making this presentation. Even though it's still a really big mystery within the universe, I hope to keep up with learning about it and potentially being here to hear about the new discoveries about it in the future. Thanks.